Hello, happy Thursday, everybody. Today's shout out will go to, let's see, Arian. I think most of you will agree that Arian is probably one of the kindest people in the classroom. He puts up with a lot at his side of the his side of the classroom, over at those tables. And for a brief moment in time, he left and went to the standing desk, which made me nervous. I thought he was giving up on the group, but he went back. Today's goal is that we factor trinomials when a is equal to 1. So let's get started. So the other day we were factoring GCFs out of polynomials. Today we're going to focus just on trinomials where the variable parts are the same, so you won't have x's with y's. And so this trinomial, the x squared and x plus a constant, the coefficient of x squared is always considered a in math, the coefficient of x is always considered our b, and the constant itself is considered c. Before we get started with factoring trinomials, we're going to figure out two binomials that will multiply together to give you each trinomial. We're going to work a couple of puzzles which help you get thinking in the way that you need to think to be able to do this. So for these puzzles, we are always looking for two numbers that multiply to give you the top number and add to give you the bottom number. So we want two numbers that multiply to give you 12 and add to give you 7. Those two numbers would be 3 and 4. And it doesn't matter which number you put where, but we're putting them on the sides. For the second one, we're looking for two numbers that multiply to give you 6 and add to give you negative 5. So if they're adding to give you a negative and multiplying to give you a positive, there would have to be two negative numbers. And those two numbers would be negative 3 and negative 2. And then for our last example, we want to multiply to get negative 72 and add to get negative 21. So one is going to be a negative number, the other one is going to be a positive number. And our larger number is going to have to be negative so that we get a negative sum. So those two numbers would be negative 21 and positive 3. So that's how you're going to be thinking when you're actually factoring trinomials. And I'll show you how this puzzle will help. So the example that we have here is we have b squared plus 8b plus 7. And we want to factor it into two binomials that will multiply together to give you this polynomial back. So we're going to take our c, and that's going to go on the top of the puzzle, and our 8 goes on the bottom. So now we want to think about two numbers that multiply to give you 7 and add to give you 8. Those two numbers would be 7 and 1. We're going to set up parentheses for our two binomials, and we're going to put b in each of those as our first term in each. And then the two numbers from the puzzle, the two answers from the puzzle, are going to go in after the b. So we have b plus 7, b plus 1. If you multiply these two binomials, you will get this polynomial back. And I'm going to use FOIL just to show you. So I'm going to multiply the two first terms and get b squared. I'm going to multiply the two outside terms and get b. The two inside terms and get 7b, and the two last terms and get 7. And if I combine my b's, I would have 8b in the middle. So now we're going to try a couple together. The first one is a squared plus 10a plus 21. So to make my little puzzle here, I'm looking for two numbers that multiply to give you the c. So multiply to give you 21 and add to give you 10. So I'm thinking of two numbers that multiply to give me 21, add to give me 10, and those two numbers would be 7 and 3. So my two parentheses would be a plus 7 and a plus 3. If you multiply these two binomials, you will get this trinomial. So this trinomial factors into these two binomials. For my next example, I'm looking for two numbers that multiply to give you negative 10 and add to give you negative 3. So one number is going to have to be negative and one number is going to have to be positive. And I know that negative 5 and positive 2 will give me negative 3. So those are my two numbers. So when I set up my parentheses, I'm going to have p minus 5 and p plus 2. These are the two binomial factors of this trinomial. For my last example, I want two numbers that multiply to give you negative 11 and add to give you 10. So I know that one has to be negative and one has to be positive, and the bigger number has to be positive because you have a positive sum. So if I try negative 1 and positive 11, if I add those two together, I would get positive 10, and if I multiply them, I get negative 11. So my two parentheses would be c minus 1 and c plus 11. And it doesn't matter which order you put the two different parentheses in. You could say c plus 11, c minus 1, it doesn't matter. But those are the two factors of that trinomial. Now, just like the other day where we used factoring to help us solve, we're going to now solve these polynomials using factoring in the zero product property. So for this first example, I'm looking for two numbers that multiply to give you 4 and add to give you 5. Those two numbers would be 4 and 1. So my parentheses would be x plus 4 and x plus 1. And I know that that equals 0. So if this times this has to equal 0, that means either this first parentheses has to equal 0, or the second parentheses has to equal 0. So here's one factor and the other factor. One of those has to be 0 in order for us to get 0 for an answer when we multiply. So now we're going to solve each of these one-step equations, and our two solutions that we're going to get are going to be x equals either negative 4 or negative 1. For the next example, I'm looking for two numbers that multiply to give you negative 7 and add to give you 6. So two numbers that multiply to give you negative 7 and add to give you 6. I know I'm going to have two negative numbers. One negative number and one positive number. And I'm going to have the larger number is going to be positive because I get positive 6. So negative 7 and negative 1 and positive 7 will give you negative 7. And when you add, you get positive 6. So my two parentheses would be b minus 1 and b plus 7. And that has to equal 0. So I know that either this factor or this factor has to equal 0 in order for this to work. So b minus 1 equals 0 or b plus 7 equals 0. If I solve this one-step equation, I get b equals 1. If I solve this one-step equation, I get b equals negative 7. So those are my two solutions, roots, or zeros for that trinomial. And then my last example, I'm looking for two numbers that multiply to give me negative 6 and add to give me negative 1. So we can try negative 3 and positive 2. They multiply to give me negative 6 and they add to give me negative 1. So my two parentheses would be n minus 3 and n plus 2. So I know that either the first factor or the second factor has to equal 0, otherwise I can't get 0 for a product. So I'm going to write n minus 3 equals 0 and n plus 2 equals 0. And I'm going to solve each of these one-step equations, and my two solutions are going to be 3 and negative 2. And then the last set of examples where it says find the zeros. Zeros are the same things as solutions and roots, so it's actually the same set of directions. You just might sometimes see factor and solve, and you might see find the zero, so you have to be prepared for both. So I'm going to do the same exact thing. I'm going to make f of x equals 0 so that when I factor this, I can use the zero product property. I'm going to look for two numbers that first multiply to give me negative 15 and add to give me 2. and those numbers would be 5 and -3. So my first parentheses would be x plus 5 and x minus 3. And so I know that either one of these two factors has to equal 0 for this to work. So x plus 5 equals 0, or x minus 3 equals 0. And if I solve these two one-step equations, I'm going to get -5 and +3 as my two possibilities. For the next one, I'm looking for two numbers that multiply to give me 14 and add to give me 9. So 7 and 2 work. So my parentheses would be x plus 7 and x plus 2. I'm going to make that equal 0. And so I know that either x plus 7 equals 0, or x plus 2 equals 0, or they both equal 0. If I solve this one-step equation, I get -7. If I solve this one-step equation, I get -2. So those are the two solutions. Roots are zeros. And then the last example, I'm looking for two numbers that multiply to give me 10 and add to give me 7. So that would be 5 and 2. So one parentheses would be x plus 5. The other parentheses would be x plus 2. If I solve the first parentheses, I would get -5. If I solve my second parentheses, I would get -2, and those are my two solutions. Roots are zeros. So if you can figure out the two numbers that multiply and add to give you what you need, you can factor your trinomial and then make each parentheses equal 0 and solve it. Have a good day.